Today we will discuss about thermodynamic spontaneity. Spontaneity means the phenomena which explain the feasibility of process. Process is feasible or not feasible. It's called spontaneity. So we will define here what is spontaneity and a spontaneous process. The process which proceed without any external intervention, or we can say that the process which does not require or process doesn't require energy during the process, or we can say that no need of energy during the process after initiation. After initiation are called spontaneous process. Spontaneous process and phenomena is spontaneity. So we will discuss here the process spontaneity by the example. First is combustion of fuels like petrol. It produce carbon dioxide, water, and heat. This is a spontaneous process. Why it is spontaneous? How can we explain to this petrol combustion is spontaneous? Because combustion of petrol require a small amount of fire for initiation of reaction. But during the reaction, no need of fire. It continuous means initiation. First molecule of petrol burn by the small amount of fire. Again, then next molecule burn by the help of released amount of heat during the combustion. So only first time initiation time requires small amount of heat, and all other molecule 10 to 100 liters of petrol burn without any external heat. Or we can say that combustion of coal also a spontaneous process because it requires fire or energy for initiation and then process completed without any external addition of energy. The process which requires energy continuous during the process also initiation of process also is called non-spontaneous process. We can have a daily life example like as movement of wheel in motor car is require continuous energy or continuous force by the piston. So movement of wheel is non-spontaneous process. It require energy or force, initiation of movement of wheel, and during the movement, also to maintaining acceleration speed, all this. So the movement of wheel is non-spontaneous process. Clear? So here is the point why we will discuss here spontaneity, or what is the daily life use of spontaneity. Actually, the spontaneity discussed for change the non-spontaneous process to spontaneous. Suppose the combustion of petrol is spontaneous when it connect with piston, then movement of piston also becomes spontaneous. Movement of piston require force continuous for movement, so it is non-spontaneous. Piston movement give the movement to wheel of motor car, so piston movement is non-spontaneous. Petrol combustion is spontaneous. If both systems are connected to each other, then piston movement will be spontaneous, because the value of heat, value of energy is very high comparison than energy required to movement of piston. So both become feasible, both become spontaneous. This is the daily life use. So we will study this point, spontaneity. This is the importance. So now we will discuss here spontaneity by energy. Why any process will be spontaneous, or why any process will be non-spontaneous? This is explained on the basis of energy. Any process, or all spontaneous process flow or proceed from high energy to low energy. This is the natural rule. Why any system or any reaction proceed high energy to low energy? Because it provides stability. The rule of nature is the stability. Whole universe proceeding or flowing towards stability. So we can write here because of stability. So what is the relation between energy and stability? We can just have an example, daily life example, to try to understand the role of stability and energy. We can example of 4 to 5 year boy is active, more active as comparison than old person, because young boy has high energy, so low stability. Old man has low energy, so more stability. Old man sitting one place long time, but young boy moving dynamically, move here and there, because it has high energy. So this is the term to explain the relation between stability and energy. This is the, I think this is the good example to understand how can a young boy is more active as comparison than old man, because old man has low energy. We can just relate to this to understand the role of energy and stability. We can write here energy inversely proportional to stability. And every system, every process requires stability. So, according to energy, we can explain here some thermodynamical potential which explain the energy in the form of thermodynamic potential. The energy in thermodynamics explained by thermodynamic potential. Potentials. Enthalpy, internal energy, Helmholtz energy, and Gibbs free energy, and chemical potential. All these are thermodynamic potential which directly relate with energy. These are energy also different variable based. So we can explain here spontaneity by help of these potential. So these potential are explained by uh, Maxwell Born square. Actually, this is out of JEE syllabus, but we can use as a trick for this. This is very simple. So we can use this. We form a square. As I know, name of this is Maxwell Born square. So we form here a square. Right top point, sorry, right top point pressure, left top point entropy, right bottom temperature, left bottom volume. These are variables. Variables means the function which uh, we can change the function which change the potential. Enthalpy gives free energy, entropy, and internal energy. We can learn this SPVT, SPVT, HGAU. We can by head this HGAU, HGAU clockwise, HGAU clockwise, and SPTV also clockwise. We can draw here arrow from entropy to temperature and pressure to volume. So this arrow is helpful to denote the value. So according to upper statement, we can say here the energy should be low during the process, or the energy decreases during the process, then the process will be spontaneous. Spontaneous process means loss of energy. If any system lost its energy, then energy of system decreases and stability of system increases. So loss of energy, energy term are enthalpy, gives free energy, Helmholtz free energy, and internal energy. So condition change in enthalpy. Suppose a process is R to P, a reaction R to P. So change during the process, change in enthalpy should be less than zero, means negative. Negative means loss of energy, are equal to zero at constant side variables, this and this. Enthalpy of a bone square has two variable, pressure and entropy. So at constant entropy and pressure, the enthalpy change will be less than 0 or equal to 0. Less than 0 means negative. Negative means the heat releases. Delta H negative means heat releases. So process will be spontaneous. Negative for irreversible. Negative for irreversible process. And 0 for reversible process. This is the point. Next term is Gibbs free energy change. Gibbs free energy change means Gibbs free energy also has two variable. If Gibbs free energy is the function of thermodynamics, then it has two variable, pressure and temperature, side by side. So here pressure constant and temperature constant, then the value of delta G will be negative, means smaller than 0 or equal to 0. Then process will be spontaneous. All this for spontaneous process. We will discuss here spontaneous process condition. Same for change of Helmholtz energy, volume and temperature should be constant. Then the value of change of delta A should be negative or equal to 0. And for internal energy also, this internal energy delta U at constant entropy and volume should be less than 0 or equal to 0. This is the condition of spontaneity. If any process has this condition, means enthalpy change at constant entropy and constant pressure is equal to 0 or less than 0, then process will be spontaneous. Or any process has Gibbs free energy change at constant temperature and constant pressure, then uh, delta G value change at constant pressure and temperature less than 0 or equal to 0, then process will be spontaneous, and so on for these two also. We can explain spontaneity according to variables also. Spontaneity we can draw here Maxwell square SP BT HG AU arrow from S to T and T to A. This is Maxwell square. Or we can use here entropy change. If entropy change of any process at constant enthalpy and pressure is greater than 0, means positive or equal to 0, then process will be spontaneous. This arrow is represent. If the arrow go far away, then process will be positive, means the value will be positive. So for entropy change, the arrow goes far away from entropy. So its value, the value of entropy should be positive. We can represent by this arrow. Another is entropy change at constant internal energy and volume, also greater than 0 or equal to 0, then process will be spontaneous. We can write here same pattern for pressure. Pressure change at what constant? Enthalpy and entropy. Entropy and enthalpy. This is also should be greater because arrow is going far away from pressure, isn't it? So process will be spontaneous. Same delta P at constant G and constant T greater than or equal to 0, then process will be spontaneous. Now we can write the spontaneity according to temperature and volume also. Temperature change, temperature change at constant pressure and gives free energy. Pressure and gives free energy, and temperature less than 0 means negative or equal to 0 for spontaneity. Why? Because arrow is coming towards temperature. If arrow coming towards, then negative. Going forward, if far away, then positive. So delta T at constant V and A less than 0, then process also is spontaneous. We can write same for volume change. If volume change take place at constant, Hertz energy and temperature is less than 0 or equal to 0, then process will be spontaneous. If the volume change at constant internal energy and entropy, internal energy and entropy is less than 0 or equal to 0, then process also is spontaneous. All this is the term to explain the spontaneity. We can write an example also. A question: which one condition is spontaneous for thermodynamical processes at constant G and T should be greater than 0. Entropy change at constant pressure and temperatures greater than 0, or entropy change at constant pressure and enthalpy less than 0 or equal to 0. In the entropy change at constant internal energy and volume greater or equal to 0. So, according to Maxwell Born square, we know that and SP, VT, HG, AU. Arrow going far away to entropy. So entropy always greater than 0 or equal to 0, not less than 0. Clear? So we will, and only two condition: enthalpy, pressure, internal energy, and volume should be constant. So this one is the correct. Here is a Entropy is less than 0. So it is incorrect. It is incorrect. And pressure temperature is not variable of entropy. So this is also incorrect. Only D is correct. The question is based on this spontaneity. Can ask in examination for this. So another terms also used for entropy. The best thermodynamic potential to explain spontaneity is Gibbs free energy. Gibbs free energy is the best thermodynamic potential to explain spontaneity. Because why it is best? So we will try to understand here by the Maxwell bond square. Why it is best? SPVT and HgAU. The change in enthalpy dH is equal to, we know that enthalpy is the function of entropy and pressure. So we change here entropy and pressure. Entropy is direct related to temperature. So TDS we can write aero is going to temperature. So T is the constant. And this pressure change at constant value. The term plus or minus is signed according to arrow. Entropy, arrow going far away, so positive. Pressure, arrow also going far away, so plus. Means enthalpy change is depend upon entropy change and pressure change. Clear? And entropy and pressure. Pressure we can change the pressure in lab by external devices, but can't control the entropy change by externally. It is a extrinsic property. Extrinsic means the change of variable is the are not controlled by external device in lab, and extrinsic controlled by outside, external side. So the explanation of spontaneity by change of enthalpy is less valuable, less important, because we can't control entropy change in lab. And dg gives free energy is the function of pressure and temperature. So dp and dt, pressure at constant volume, where is air is going, the pressure to volume is constant, and air sorry, arrow going towards volume means far away to pressure, so term will be positive. And here in case of temperature, the arrow coming towards temperature and entropy is constant, so term will be negative. Okay, if arrow coming to your variable, then will be negative. And both pressure and temperature can be controlled in the lab because this is extrinsic property. We can discuss here what is intrinsic and extrinsic. Intensive and extensive is the different. Extensive means mass dependent and intensive means mass independent. Variables are terms, thermodynamical terms. But extensive, intensive is the different term. Extensive means a function which controlled in lab by external device, but intrinsic is not controlled inside the lab. So delta dA also is the function of volume and temperature. So volume is related to pressure. So dV at constant P, the arrow coming towards your variable term, so negative, and here is also negative dt, because your arrow coming side your variable T and constant entropy. Here temperature is extrinsic, but volume is intrinsic during the process. We can say that the adding of mole we can change volume, but during the process we can't add the mole of any matter, so volume can't change. This is a intrinsic volume change by the interanic interactions. If interanic interaction decreases, volume increases, interanic interaction increases, volume decreases. So it is intrinsic property. It is not extrinsic. Temperature is extrinsic property. So Helmholtz energy also uh, less applicable or less valuable, and internal energy change also is the function of entropy and volume. So change in entropy and change in volume at constant pressure, volume change, and arrow coming to your variable, so it will be negative. And arrow going forward to your variable, this entropy, so it will be positive, and constant is temperature. This is also both are extrinsic. So here is extrinsic. We will discuss extrinsic property. Means controlled properties which can control lab. Intrinsic cannot control. So pressure and temperature, these two are extrinsic. Extrinsic means we can the change of value of pressure and temperature from external environment, and entropy and volume is intrinsic properties. These are depend upon volume is depend upon intermolecular attraction. If intermolecular attraction increases, volume decreases. Intermolecular attraction decreases, volume increases. So the intrinsic property. We can say here by adding mole, by applying pressure is then pressure is the main factor. By increasing mole, then mole is the main factor. Then if you change the mole and change in volume, mole change in then chemical potential, that part will be chemical potential. So we will here use to change in and gives free energy, because the variable, both variable are one point is here also, extrinsic and extensive, both are different. Extensive means mass dependent, extrinsic matlab externally controlled, and same intensive means mass independent, and extrinsic means internally dependent, internal property, not controlled by external. Okay, so here SDT. So pressure also controlled by external environment and temperature also. So we will discuss the spontaneity by help of G. And another point in metallurgy, we know that Friendlich diagram, sorry, Lingam diagram. Lingam, so is the diagram between gives free energy change, which is based on RT ln pressure of O2 gas and temperature, which explain the visibility of carbon reduction of metal oxide. We know that Lingam diagram is explain the metal oxide reduction known as carbon reduction, means reduction of metal oxide through by the help of carbon. Suppose Fe2O3 in presence of carbon, it will reduce into Fe and CO. So here is plus 3, here is 0. So metal undergo reduction. Why? Because of addition of carbon. So it is called carbon reduction. Then a Lingam diagram explain the carbon reduction. We will discuss to this in next class, next lecture, the Lingam diagram and temperature based spontaneity, means what is the role of temperature to change the spontaneity, non-spontaneity of the process by G. Okay, so